Bismillahirrahmanirrahim. Assalamu alaikum. Dear students, in the previous two lectures, we have discussed what is cement. Then we have discussed that there are two major types of cement. The first one is hydraulic cement, the cement which become hardened in the presence of water just because of hydration. After this, we have discussed the second type of cement, which is known as non-hydraulic cement. And non-hydraulic cement is that cement which does not become hardened in the presence of water, but it becomes hardened when it is treated or when it reacted with the carbon dioxide, which is known as carbonation. Then we have said that if we change the input chemicals, then we will get different types of cement, which we can use in the different areas or which we can use for the different conditions. Then we have discussed the machinery which is being used for the transportation of rocks to the industry, like dumpers, excavators. Then after this, we have discussed the major equipments which are being used in the cement industry for the production of cement, in which the first one was quality checkers. Then there were preheaters, kilns, coolers, silos, different equipments we have studied. After the equipments, we have studied the raw material for the cement production. In the raw material, we have discussed limestone, then chalk. After that, we have discussed marl. Now, the second component which is very important in the cement production is clay. So today we are going to discuss second component for the production of cement, and then we will discuss wet process and dry process. These are the two major processes which are being used in the production of cement in cement industry. So first of all, clay component. The other important raw material for the cement manufacture is clay. It means after the limestone, marl and chalk, the most important component of raw material in the cement production is clay. Clay is formed by the weathering of alkali and alkaline earth containing aluminium silicates and of their chemical conversion products, mainly feldspar and mica. The main component of clay is formed by hydrous aluminium. The chemical composition of clay may vary from those close to the pure clay to that containing a considerable amount of chemical admixture as iron hydroxide, iron sulfide and sand. With sand there is calcium carbonate, etc., etc. And the last point is iron hydroxide is the principal coloring agent in the clay. Also, organic matter may give the clay different colors. Clay with no impurities are white. The major source of alkali in cement is found in the argillaceous components of the raw mixture. Now students, I'm going to explain these 3 points one by one. In first point, he explained that clay is the major constituent of raw material. After the chalk, limestone and marl. Then he explained that clay is formed by the weathering of alkali and alkaline earth which contain aluminium silicates. Then in the second point, he explained that the major component of clay is found by the hydrous aluminium. Then He also explained that clay must contain, or maybe clay contain different impurities like iron hydroxide, iron sulfide, sand, and calcium carbonate. And in the third point, he explained the color of clay is due to the presence of iron hydroxide or due to the presence of organic matter. If there is no impurity in the clay, then clay will be in white color and this will be your pure clay. So these were 3 points which he explained in this slide. Students, now our next topic is manufacturing process of cement. Students, in this process we will discuss different equipments which we have studied in the previous lecture. Now I will explain all of these steps one by one. So the first point is production of cement completes after the passing of raw material from the following 6 phases. Student, he said that cement is manufactured after passing the raw material different phases. Those are 6 in number and we have explained all of those earlier in the previous lecture. Now the first phase is raw material extraction and quarry. Students, as you know that we have discussed, we use excavators for the digging of raw material or for the digging of different rocks. Then we use dumpers to transport that rock or the raw material toward the industry. And as we know that after an industry we use different quality checkers. We check the quality of limestone. So the first point and the first phase is quality checkers, where we check the quality of our limestone. Now the second is grinding, proportioning and blending. So students, as you know that after checking there were reject belts which we have used. After that we have used grindings or the grinders. Those grinders grind the raw material into small pieces or into powder form. Then we use different silos which homogenize our raw material. After homogenizing, we have fed the raw material to the preheaters, and here our next phase is preheating phase. In the preheating, we heat the raw material and the carbon dioxide is removed and vapors will also remove. After that, after the preheating, homogenizing, we fed our raw material to the kiln. So our fourth phase is kiln phase. As you know that kiln is insulated chamber like oven which produce heat which is necessary for the different chemical reactions which are necessary for the production of cement. After the kiln, now it is turned to cool down the cement. So our fifth one phase is cooling and final grinding. Here we use different coolers to cool the cement like clinker coolers or grate coolers. We use these two types of coolers to cool down the cement. After the cooling and final grinding, it's turned to packed it. Now our last phase is packing and shipping. Here we pack the cement and shipped it towards the market. So students, these were the 6 major phases which are very necessary or which are very important in the cement industry. After passing these 6 phases, raw material is converted into the cement. Students, as you know that manufacturing of cement start from the digging of rocks by the excavators, which is known as mining. So in the manufacturing of cement, our first point is mining. The cement manufacturing process start from the mining of raw materials that are used in the cement manufacturing, mainly limestone and clays. The clays are excavated from the open cast mines and loaded onto dumpers which transport the materials and upload into open yard storage. Other raw materials are used to control the kiln fed mixture design, namely sand and iron ore. So students, what he said in this point? Students, he said that the raw material for the production of cement is excavated and transported to the industry. The raw material for the cement production is limestone and clay. The other raw material which used to control the kiln fed mixture is sand and iron ore. Next point is the manufacturing process of cement involve either a dry process or a wet process. The choice of a dry or wet process depends upon the following factors: physical conditions of raw materials, local climate conditions of the factory, the price of the fuel. Students, as I have explained earlier, there are two important methods for the production of cement: dry process and wet process. In this point, he explained that there were two important methods for the production of cement: dry process and wet process. Now, which process will be adopted depend upon the following condition. The first one is physical conditions of the raw materials. Second one was local climate conditions of the factory, and the last one is the price of fuel. So these are the important and major reasons or the major conditions which decide which method will be used to produce the cement. It may be dry or it may be wet process. Now students, in the manufacturing of cement, we are going to discuss first process for the manufacturing is wet process. And in wet process, the first point is during the wet process, the raw mixture is fed into kiln in the form of slurry that may contain water up to 30 to 40%. In the wet process, the kiln is very long tube in comparison to dry process, and the slurry that is easy to blend and homogenize due to water is directly being fed into the kiln. Student, in this point he said that in the wet process we use slurry of raw material which may contain 30 to 40% of water, and that slurry is directly fed into the kiln, which is very long as compared to the dry process. Because the raw material is in the form of slurry, it is easy to blend and easy to homogenize and directly fed into the kiln. I'm going to explain it again. Student, he explained that in the wet process, we fed the raw material in the form of slurry directly to the kiln. It may contain 30 to 40% of water. He also explained that the homogenizing and blending of raw material in the wet process is easy because there is the contamination of water in the raw material. So, because homogenizing and blending is easy, so slurry is directly fed into the kiln. Now, the second point is wet process could be selected as manufacturing technology is when raw materials have natural high moisture content. The amount of moisture in minerals sometimes can be even more than 12%, as in case of chalk and in marl stone. The use of wet process is also essential when relatively poor grade limestone need to be enriched through the process. Now in the second point, students, he is explaining the advantages of wet process. He said that in the wet process, you can use the raw material which may contain the water or the moistures, even more than 12%. It is in the case of chalk and marl stone. He also explained that this is also the advantage of wet process, as you can use the poor grade limestone in this process. So students, in the second point, he explained that wet process is being used when raw material include moistures. And in this point, he also explained that in this process, you can also use lower grade limestone to produce the cement. Now the last point is, in this process, water is required as process medium. Until 1950, most of the cement processing kilns were wet kilns due to the ease of blending and homogenizing the components of raw mixture. In the wet process, the fuel consumption is in the range of 1300 to 1600 kilocalories per kilogram of clinker. Power consumption in the manufacture process is about 110 to 115 kilowatt hour per ton of cement. So students, in this point, in the third point, he explained that till 1950, the kilns were wet kilns in the manufacturing of cement because the raw material for the wet process is slurry, which contain water. Due to that water, the blending and homogenizing is easy. So it will be low cost process for the production of cement. And at the end, he explained the energy consumption, the fuel consumption for per ton production of cement. So students, these were the three important points of wet process. In first point, he explained that you can use wet process when there is 30 to 40% contamination of water in your raw material. And in the wet process, the slurry of raw material is fed directly to the kilns. In the second point, he explained that you can use the low grade limestone in this process. And at the end, he explained that till 1950, cement industries use wet kilns because the use of slurry is very easy to produce cement because blending and homogenizing is very easy. So students, after the brief introduction of wet process, now we are going to explain different processes which are involved in the wet process. And in those processes, the first process is crushing and grinding. The limestone is crushed in the first crusher called as jaw crusher and then fed into the second crusher called as impact crusher with mixing of clay to reduce the particle size below 50 mm or 50 millimeters. Students, for the crushing in the wet process, there are two crushers. The first crusher is known as jaw crusher and the second crusher is known as impact crusher. And these crushers are being used to reduce the size of raw material up to 50 millimeters. Now the second point is the discharged raw mixture, which contain limestone 70%, clay 30%, is fed into a belt conveyor and passed across a bulk material analyzer. First of all, students, your raw material is crushed now. Now that crushed raw material is passed through the belt conveyor, where the quality is checked and the good quality limestone is transferred to the next phase, and the bad quality limestone is conveyed outside the plant by the reject belt conveyor. Now the third point is the raw mixture is fed into a circular storage unit called a raw mixture storage. Then the mixture is extracted transversely from the stockpiles by reclaimers and conveyed to a raw mill bin called the raw mixture bin for grinding. Students, in these 3 points, he explained that we crush the mixture or we crush the raw material by two crusher. The first one is known as jaw crusher and the second one is known as impact crusher. These two crushers convert the raw material particle into the size 50 mm or 50 millimeters. Now that mixture is fed into the analyzer where it is analyzed that good quality limestone is fed into the next phase while the bad quality limestone is rejected through the reject belt conveyor. After that, that mixture is fed into the raw mixture storage. From raw mixture storage, this raw material is fed into the raw mixture bin where it is grinded. Now, what will happen to it next? We will discuss next. The other raw materials that are used in cement manufacturing called additives are high purity limestone, sand and iron ore. The high purity limestone is crushed in a lone in jaw crusher and then crushed more in secondary crusher to reduce the size to completely pass through a 50 mm sieves. Student, in this point, he explained that except clay and limestone, there are some other raw materials which are known as additives, which includes high purity limestone, sand and iron ore. The high purity limestone is crushed first of all in jaw crusher, then it is passed through secondary crusher which is known as impact crusher to reduce the size of particles of raw material up to 50 mm. Now the second point is then it is stocked by a limestone stocker into longitudinal storage unit called the limestone storage stockpile. Finally, the limestone is extracted transversely from the stockpile by the reclaimer and conveyed to raw mill bin called limestone bin for grinding. Now the next one is mixing of raw material. The crushed materials from different silos and basins are drawn in correct proportions where limestone is 75% and clay is 25% in a channel called wet grinding mills. Both the materials are intimately mixed in the presence of water and to form a fine thin paste known as slurry. Slurry, which contains 35 to 45% water, is sometimes filtered to reduce the water content from 20 to 30%. This reduces the fuel consumption of heating storage. Slurry is then stored in another silo, maybe called as slurry silo, where it is constantly stirred. The composition of raw materials is checked again and if required corrected by adding clay or chalk materials as desired. Students, in these 4 points, he explained that how raw material is converted into slurry. And that slurry, maybe it contains 35 to 45% of water. If it contains 35 to 45% of water, then there will be more consumption of fuel for the heating. So, to overcome this cost, we filter the slurry to reduce the water content in slurry, which also reduce the use of fuel for the heating purpose. He also explained that the slurry is stored into the slurry silos, and he also explained in the last point that the quality of slurry or the composition of slurry is checked again and again. If it is necessary, then there may be the addition of clay or chalk material as desired for the production or for the composition of slurry. After the preparation of slurry, which may contain 20 to 30% water content, now it's turn to heat that slurry into the kiln. And the next process is heating the slurry in a rotatory kiln. And the first point in this process is raw meal or slurry prepared as above is introduced into the rotatory kiln with the help of conveyor. The rotatory kiln consists of a large cylinder 8 to 15 feet in diameter and 300 to 500 feet in length. Students, in this point, he explained that the raw meal slurry prepared and introduced into the rotatory kiln, and that rotatory kiln has large cylinder whose diameter is 8 to 15 feet and length is 300 to 500 feet. Now the second point is it is made of steel and lined inside with the fire bricks. The kiln rotates horizontally on its axis at the rate of 1 to 2 revolutions per minute, and it is inclined a few degrees. As kiln rotates, the charges is heated by burning coal, oil or natural gas. In the second point, he explained that kiln is made of steel which is lined with the fire bricks, and that kiln rotates horizontally on its axis, and the speed of its rotation is 1 to 2 revolutions in 1 minute. And he explained that kiln is inclined in some degrees. And at the end, in this point, he explained that this kiln is heated by burning coal, oil or the natural gas as a fuel. So in first point, he explained that slurry is fed into the kiln. That kiln has cylinder whose diameters are 8 to 15 feet and length is 300 to 500 feet. And in the second point, he explained that kiln is formed of steel which is lined with the fire bricks. Then he explained that kiln rotates horizontally in 1 to 2 revolutions in 1 minute, and it is inclined in few degrees. He explained that we use coal, oil and natural gas as a fuel for the burning of or for the heating of raw meal. And at the end, he explained that in the rotatory kiln, the charge passes through the different zones of temperature where the different reactions take place. The charge takes place 2 to 3 hours to complete the journey in the kiln. Students, in the kiln, there are different stages of temperature, which we will discuss in the next slide. Our raw meal or the charges require 2 to 3 hours to complete the journey in the kiln. So students, these were the 3 important points in the heating the slurry in the rotatory kiln. Now in the next slide, we will discuss these 3 stages which are in the kiln for the temperature. As students, we have explained in the previous slide that the slurry is fed into the kiln and there are three different stages in the kiln of temperature by which the raw material is passed through, and it requires 2 to 3 hours to pass through the kiln. Now, the first stage of the temperature is drying or preheating zone. This heating zone is the minimum temperature zone. In this zone, the temperature is kept at 500 degrees centigrade, whereby the moisture is removed and the clay is broken into aluminum oxide, silicon dioxide and iron dioxide or iron oxide, sorry. Students, in the first zone, which is known as drying or preheating zone, in this zone, the temperature is kept up to 500 degrees centigrade. Here, the moistures are removed and the clay is broken into the aluminum oxide, silicon dioxide and iron oxide. Is it clear or not? Now, the next stage is decomposition zone, which is moderate temperature zone or calcination zone. Here, the temperature goes up to 900 degrees centigrade to 1000 degrees centigrade. In this zone, the limestone calcium carbonate decomposes into the calcium oxide and carbon dioxide. Students, after the drying or preheating zone, there is the moderate temperature zone, which is also known as calcination zone or decomposition zone. Here, the temperature goes up to 900 degrees centigrade to 1000 degrees centigrade. Here, the limestone is decomposed into the calcium oxide and carbon dioxide. So students, these were the two zones of temperature in the kiln which we have discussed. First one was drying or preheating zone, where the temperature is kept up to 500 degrees centigrade and clay is broken into aluminum oxide, iron oxide and silicon dioxide. Into the second point, decomposition zone, the temperature is kept up to 1000 degrees centigrade, from 900 to 1000 degrees centigrade. Here, limestone is converted into calcium oxide and carbon dioxide. Now, the last temperature zone is burning zone, which is maximum temperature zone. In this zone, the temperature goes up to 1500 degrees centigrade and the oxides, for example, calcium oxide, silicon dioxide, aluminum oxide and iron oxide combine together and form calcium silicate, calcium aluminate and calcium ferrate or ferrite. Students, in the last zone, he explained that the temperature goes up to 1500 degrees centigrade and the oxides like calcium oxide, silicon dioxide, iron oxide and aluminum oxide, which we have prepared into the previous two zones, will combine together and form calcium silicate, calcium aluminate and calcium ferrite. And the temperature in this zone is 1500 degrees centigrade. So students, these were the three major zones of the temperature into the kilns. In the first zone, which is known as drying zone, temperature is kept up to 500 degrees centigrade. Second zone, which is known as decomposition zone, and the temperature is kept up to 900 to 1000 degrees centigrade. And last temperature zone, which is known as burning zone, and the temperature is kept up to 1500 degrees centigrade. Next zone is cooling zone. Usually, with few exceptions, the last 3 to 6 meters of the discharge end of the kiln. Contrary to popular misconceptions, the process of clinker formation is not complete when the material has the hottest area. And the second point is the manner in which the clinker is cooled greatly affects the quality. Depending on the location of flame cooling, solidification of partly liquid compounds can be either slow or rapid. It is generally true that rapid cooling is beneficial to both the quality of the clinker and its grind ability. For rapid cooling, the centering zone is very close to the discharge end, thus the old clinker discharges from the kiln at the temperature of about 1370 degrees centigrade, which is 2498 Fahrenheit. As soon as it enters the first quench compartment in the cooler, it is rapidly cooled. Conversely, when the burning zone is located too far uphill, the clinker will reside from a longer time in the lower transition zone, being slowly cooled and thus discharged from old kiln at the temperature of around 1200 degrees centigrade, which is 2192 Fahrenheit. So students, these were 4 important points in the cooling zone, where different temperature ranges are mentioned, like 1370 and 2192 Fahrenheit. Now the next process is clinker formation. The resulting product obtained from the kiln is known as cement clinker. This has the appearance of greenish black or grey colored balls, varying in size from small nuts to peas. Students, the material which is obtained after the cooling from the kiln is known as cement clinker. This material has appearance like greenish black or grey colored balls in size from small nuts to peas. Now students, the next procedure or the next process is grinding the clinkers with the gypsum. The cement clinkers are then air cooled. The required amount of gypsum is first ground to a fine powder and then mixed with clinker. At this stage, finished cement is pumped pneumatically to storage silos, from where it is drawn from packing in paper bags or for dispatch in bulk containers. So students, last process is packing and dispatching. Cement from silo is extracted and fed to the rotatory screen with the help of air slits and bucket elevators. The rotatory screen removes the foreign particles present in the cement and is fed to the packer's hopper, from where the cement is then fed to the respective packers for weighing and packing. 2 types of packers are used. One is mechanical type rotatory packer and other is electronic type rotatory packer. The cement is packed in 50 kg bags and is conveyed to lorries or wagons for dispatch. So students, these were total processes which are involved into the wet process. We have explained them one by one. Students, here is the flow diagram of wet process. My dear students, if you have knowledge of wet process, then you can easily explain this flow diagram, or you can easily write this flow diagram, as you know that there are 2 major materials, raw materials, which are being used in the wet process. The one is limestone and the other one is clay. So here in the figure you can see that in one side there is limestone and on the other side there is clay. As you know that limestone is first crushed, and for this purpose it is fed into the crushers. There are 2 types of crushers. One is jaw crusher and the second one is impact crusher. After the crushing, this material is converted into the size of particles 50 millimeters and then fed into the storage basins. On the other hand, clay is fed into the wash mills, from where it is fed into the storage basins. These both of storage basins are also known as storage silos. From both of these silos, both of the raw materials are then fed into the wet grinding mill, which produce the slurry. Now that slurry is fed into the blending silos where it is blended to the correct composition. What it means, here the composition of slurry is checked. If there is need of any kind of raw material like limestone or clay, then it is added. After that, that correct composition slurry is stored into the storage silos. Now that correct composition slurry is now fed into the kilns, where, as you know, that their heat is produced and that slurry is converted into the clinker. When that slurry is converted into the clinker, after that, as you know that clinker is formed, then there is the grinding of clinker with the gypsum. So here there is clinkers are ground in ball mill with the 2 to 3% gypsum. When that is grinded, now that clinker is fed into the cement silos, and after the cement silos, this cement is produced. Now it is packed. So at the end there is the packing plant. So here at the end you can see that there is the packing plant. You will pack your cement and ship it toward the other areas of your country or of your city. So students, this was the flow diagram of wet process.